Welcome to the Explainer. So, if you've been following the generative AI space recently, you've definitely heard the word agent thrown around a lot. It's everywhere, right? But how do you actually build one of these systems so that it works reliably? Well, to wrap our heads around this, I want you to imagine a bustling, high-end restaurant kitchen. Just like a world-class restaurant needs that perfect blend of specialized staff, strict routines, and adaptable chefs, an effective AI system needs the exact right architectural patterns. We're going to use this kitchen analogy today to break down the foundational mental models you absolutely need to start building agentic systems.
Here is our roadmap for the top 5 core concepts. We'll be looking at agents versus workflows, routing, context, orchestrator workers, and tool optimization. And really, this quote from Anthropic perfectly captures our guiding philosophy for all of this. They looked at dozens of teams and found that the most successful implementations don't rely on massive, overly complex frameworks. No, they use simple, composable patterns. If you're just getting started, that is the best news possible. You don't need to over-engineer the whole shebang. You really just need to know which simple pattern to use and exactly when to use it. All right, Section 1, agents versus predictable workflows. Let's step right into the back of our metaphorical restaurant to see how different tasks are handled. Okay, first key term to lock in, agentic system. Now, Anthropic actually uses agentic system as a big umbrella term. It covers both strict predefined workflows and those fully autonomous agents. The defining factor here is simply that large language models are dynamically directing their own processes and using tools to get a job done. But underneath that big umbrella, there's a super important distinction we need to make. Think of a workflow like an assembly line worker at a fast food joint. They are making the exact same burger, following the exact same predefined path every single time. It's incredibly predictable. An agent, though, that is your dynamic head chef. If a key ingredient suddenly goes missing or a VIP customer has some wild special request, the head chef can pivot on the fly, make decisions, and still figure out how to plate a brilliant dish. Basically, workflows give you consistency for well-defined tasks, while agents give you flexibility for the open-ended stuff. To make this super concrete, let's look at a classic predictable workflow called prompt chaining. You take a task and you break it down into fixed subtasks. The LLM handles step 1, passes that output directly to step 2, and so on, running programmatic checks along the way. You are intentionally trading a bit of speed for much higher accuracy on a task that's easy to map out. It's literally the perfect recipe for a predictable dish. Moving on to Section 2, routing for specialized tasks. Let's walk to the front of our restaurant and see how we handle the incoming dinner rush. Second key term to memorize, routing. Routing is simply a workflow that classifies an input and sends it off to a specialized downstream task. Think of it exactly like the restaurant's hostess. When customers walk in, the hostess directs the traffic. A VIP wanting a private dining experience gets routed to the fancy back room, right? Meanwhile, a casual walk-in who just wants a quick drink gets routed to the bar. The absolute crucial point here is separation of concerns. Anthropic's research highlights that if you try to optimize one single prompt to handle every conceivable type of input, it's actually going to hurt your overall performance. Instead, you use a routing model. You send customer service refund requests to one specific tool and technical support to another. Or even better, you can save a ton of money by routing easy questions to a smaller, faster model like Claude Haiku, while saving the really heavy, complex coding questions for a highly capable model like Claude Sonnet. Section 3, context and managing the AI's memory. Let's head back to the chef's counter and see just how much information our AI chef can actually juggle at once. All right, third key term for the memory banks, context engineering. We used to obsess over prompt engineering, just finding the magic words. But context engineering is way broader. It's the strategy of curating the exact minimal set of information, the tokens that the AI has access to. Imagine our chef's working memory, or the physical counter space they have for their recipe books. If that counter is completely cluttered with 50 different cookbooks, the chef is going to get confused, overwhelmed, and slow down. And this brings us to a punching absolute truth from Anthropic. Context is a finite resource. They warn about something called context rot. See, even though modern AI models can technically accept massive amounts of text, their attention budget is still strictly limited. If you stuff your prompt with a bunch of irrelevant information, the AI's ability to recall the stuff that actually matters degrades. So the goal of context engineering is to find the smallest possible set of high signal information. You gotta keep the can clean. Okay, Section 4, orchestrator workers for complex goals. Now we are scaling up to handle a massive banquet order that one single chef could never pull off alone. This brings us to key term number 4, the orchestrator-workers workflow. It's pretty much exactly what it sounds like. A central AI, our head chef, gets a huge, unpredictable order. It dynamically breaks that order down and delegates specific prep tasks to worker AIs, the sous chefs. So the sous chefs go off, they chop the onions, they sear the meat, and then they pass it all back to the head chef who synthesizes everything into the final plate. Now, Google recently published some research on scaling these agent systems, and they revealed something super surprising. A lot of folks just assume more agents equals better results, but Google found that's actually a myth. If a task is highly parallelizable, like financial reasoning where different agents can analyze different revenue streams all at the exact same time, a centralized multi-agent system creates a massive 80.9% improvement. But if the task is sequential, meaning step-by-step planning where step B relies entirely on step A being finished, adding more agents actually degrades performance by up to 70%. The communication overhead between all those agents just completely ruins the cognitive budget.
So choosing the right architecture is vital for safety and reliability. Google pinpointed a really specific number here, 4.4. When you use an orchestrator-worker system, errors are amplified by 4.4 times. Now, I know that sounds bad until you compare it to a system of independent agents just working on their own without a central orchestrator. In that setup, errors cascade completely out of control, amplifying mistakes by up to 17.2 times. The orchestrator acts as a vital quality control checkpoint, basically catching a bad dish before it ever leaves the kitchen. Finally, Section 5, Building Better AI Tools. Let's zoom in and look really closely at the actual utensils our AI chefs are holding to get the job done. Fifth and final key term to memorize, tool optimization. In the AI world, a tool is basically just a snippet of code that lets the AI interact with the outside world, like searching a database or scheduling a calendar event. Optimizing these tools is like giving our chef a perfectly pre-sharpened, task-specific knife, instead of just handing them a raw block of iron and saying, hey, go cut that tomato. Anthropic lays out some fantastic best practices for tool optimization. First off, don't just hand the AI a massive, broad API wrapper. Give it highly specific tools. Use namespaces like Asana Search versus Jira Search so the AI doesn't get confused about which database it's actually digging into. And this is a big one. Return semantically meaningful data. Don't return a random string of numbers or low-level UIDs that read like robotic database code. Return actual text the AI can read like Jane Doe. Also, remember that finite context limit we talked about? Optimize your tools for token efficiency by truncating those really long responses. And lastly, you literally have to prompt engineer the tool descriptions themselves so the AI understands exactly how and when to pick up that specific knife.
Truly understanding these concepts is a total game changer. Google actually developed a predictive model and found that just by looking at the properties of a task, like how many tools it requires and how sequential it is, they can determine the absolute optimal agent architecture 87% of the time. Building AI systems is rapidly transitioning from a guessing game into a highly predictable science.
So we've explored the kitchen. We understand agents versus workflows, routing, context engineering, orchestrator workers, and tool optimization. We are officially moving way past the days of just typing simple text prompts and crossing our fingers. The real power now is in engineering these systems. So my question to you is, which of these 5 patterns are you going to build into your next project first? Thanks so much for joining me on this explainer, and happy building!